So let's take a problem where I have 9 square multiplied with 1 plus 3 raised to negative 1. So in this case, I first expand the brackets by multiplying this to each of the terms. Then after I expand through brackets, then I try to simplify individually for each of the terms. And then I attempt to use the 7 laws of indices which we have discussed in the previous session. So first I multiply 9 square to 1 and then I multiply 9 square to the next term 3 raised to negative 1. So I get 9 square multiplied with 1 in the first case and then plus 9 square multiplied with 3 power minus 1. Then after that I simplify the first term as 9 square would be 81 times of 1 plus 9 in this case can be written as 3 square raised to 2 times 3 power minus 1. So I am attempting to write this in this form so that I make the bases equal and then use the first law of index. So this is how I expand indirectly with 3 square whole raised to 2 times of 3 power minus 1. Next, 81 times of 1 would be 81 plus this can be written as 3 times of 2 into 2 using one of the law of index, which we all know that a power m whole power n is a power mn. Next, times of 3 power negative 1. This would be nothing but 3 power 4 into 3 power minus 1. Now here I identify the first law of index where the bases are equal, therefore I add the powers. So therefore the next step would be 81 plus 3 power 4 plus minus 1, where the powers are added because the bases are equal, the first law of index. So this would give me 3 power 4 minus 1, which is 3. So indirectly this is nothing but 81 plus 3 cube, which is 27. So this would be nothing but, when I just simplify this, would be 108. So my simplified answer is 108 for the given problem. 9 square into 1 plus 3 raised to negative 1 is 108. So every problem has got its own way of proceeding with a step-by-step process. So this is one of the example just supporting how different problems can be simplified in different forms. So let's take one more problem which may have a different approach. Let's see how the approach is out here in this problem. Yes, if I have a problem this is the problem and I want to simplify this using the laws of indices. So initially what I'm going to do is I'm going to multiply this 3 raised to negative 1 to each of the terms 2 power minus 1 and 5 power minus 1. This is how I expand the brackets. So then in this case this would become 3 raised to negative 1 times of 2 raised to negative 1 plus 3 raised to negative 1 times of 5 raised to negative 1. So this is how the brackets are expanded individually for each of its terms. Now in this case I identify that the powers are equal but the bases are not equal. So I cannot use the first law of index. But I can use a property which says that a power m into b power m is ab whole power m. So let's raise that to the common power negative 1. So this can be written as a times of b whole power m plus 3 times of 5 whole power minus 1, which would be nothing but 3 times of 2 is 6 power minus 1 plus 15 power minus 1, which indirectly gives me with the next law of index. So what is the law of index identified here? This is in the form of a power minus n, which is 1 by a power n. Therefore 6 power minus 1 can be written as 1 by 6. 15 power minus 1 can be written as 1 by 15. The negative power reduced to the positive power or the fractional form. Now this would be nothing but with the LCM. So what is the LCM of 6 and 15? 3 times of 2 and 3 times of 5. 10 to 30. So 30 is the LCM of 6 and 15. So I get 6 times of 5 multiplied with 1, which is 5. And 15 multiplied to 2 is 30 and 2 times of 1 is 2. So this would give me the overall answer as 7/30. So therefore, my answer for the question 3 raised to negative 1 times of 2 raised to negative 1 plus 5 raised to negative 1 is 7 over 30. So this is how we simplify using the laws of indices. Now we'll attempt to solve few of the exponential equations using one of the most important property. This is away from the 7 laws of indices which I have discussed, and this is one of the most important property which helps us in solving many of the exponential equations. So let's see what the property is. If I have a power m equal to a power n with the bases being equal, then in that case my powers will be equal. The property says that if a power m is equal to a power n implies m must be equal to n. Only then we have these two equal. Without this condition, these two can never be equal, provided the bases are equal. So using this property, there are many equations, the exponential equations which we are going to solve, and let's see how that can be done. Say for the example, my question is solve for x, and the question is 2 power x is equal to 32. I want to find the value of x which satisfies the exponential equation 2 power x equal to 32. This is called an exponential equation because this is having an unknown in the power. So such equations are called exponential equations. An unknown in the power or exponent form is called an exponential form, and an equation form is an exponential equation. Now to solve or find the value of x for this equation, we use this property, and that is how we get the value of x. Let's see how. Now in this case, the given exponential equation is 2 power x equal to 32, where I am going to substitute further with 2 power x equal to 32, which can be written as 2 raised to 5. When I multiply 2 5 times, I get 32, which makes me understand that this can be written as 2 raised to 5. Now the reason why I have written this in this form is I want to reduce this into the form which I have taken in the initial case. Now I have a power m equal to a power n implies m equal to n. When the bases are equal, the powers must be equal in an equation. Therefore, when 2 power x equal to 2 power 5 with bases being equal, then my next immediate case would be that the powers are equal. This is how I get the value of x using this property. So remember, it's always very important to understand this formula as when bases are equal, powers are equal. Inequality in this equality case. So therefore, when the bases are equal, I directly get x to be equal to 5. So for this exponential function, this is the solution. So x equal to 5 is said to be the solution for this exponential equation. That means x equal to 5 satisfies this equation. So next, if I have a case where 3 power 2x minus 1 is equal to 81. I wanted to find the value of x. Then immediately I try to understand that I have to make the bases equal. If I make the bases equal, I can find the value of x as I've done in the previous case of the previous problem. So for that, I'll try to reduce 81 to 3 power something. So let's see how we can do that. Now 3 power 2x minus 1 is kept fixed without disturbing anything on the left hand side. Now 81 can be written as 3 multiplied 4 times, that is 3 raised to 4. Therefore 3 power 2x minus 1 would be equal to 3 power 4, because 81 can be written as 3 multiplied 4 times, that is 3 power 4. Now in this case, the bases are equal. Therefore, what is the next case? The powers must be equal. powers must be equal. And what are the powers here? I identify the powers to be 2x minus 1 and 4. Therefore, these two must be equal according to this formula, which is very important. So therefore, 2x minus 1 would be equal to 4. That implies 2x is equal to 4 plus 1 when I bring negative 1 to the right. When I continue on the right side, I get 2x equal to 5. That implies x is equal to 5 over 2. So this is the value of x which satisfies this equation. That is, when I substitute x equal to 5 over 2 on the left side and simplify, I get the value exactly as 81. So instead of going by trial and error method of finding the value of x, we have a method where we use the formula and then find the value of x. So this is how the exponential equations can be solved. But there are some equations which are more further complicated than this. Let's see one of the case here. Now let's take another problem which is a bit more complicated than the previous case. Now this is the problem where I need to find the value of x, where the exponential equation is 3 raised to x is equal to 9 times 27 raised to 3x minus 2. So in this case, let's see how we can find the value of x. So the left hand side is with 3 power x. Now I want to make the right hand side also raised to 3 because I have to make the bases equal to make the powers equal. So therefore, let's make the base equal on the right hand side. So for that, what I do is 9 can be written as 3 square, which is nothing but one of the cases of making the base equal of 3. And the next is 27, which can be written as 3 raised to 3, which would be power 3 and whole power 3x minus 2 undisturbed. Now after doing this, I revisit the laws of indices, the 7 laws of indices, because I need to use the laws of indices out here. So let's see how again we recap with the laws of indices in case of this problem. So when I have 3 power x is 3 square times 3 power, this is identified as a power m whole power n, which is a power mn, which you have taken in the laws of indices. So a power mn is a power 3 times 3x minus 2. This is how it gets reduced to this form. Now that's nothing but 3 square times 3 power 3 times of 3x is 9x, 3 times of 2 is 6. So this is how I get when I expand the brackets. Now again I identify another law of index here, the first law of index, which says that a power m into a power n is a power m plus n. So therefore I get this as a power m plus n. So I add the powers when the bases are equal under multiplication. So in this case I get it as 3 power 2 plus 9x minus 6 would be 9x plus 2 minus 6 is minus 4. On the left side being 3 power x. Now 3 power x is equal to 3 power 9x minus 4. So from there I get this to be reduced to the above formula, which says that a power m is a power n implies m equal to n. So when the bases are equal, the powers are equal. Here bases are equal, therefore powers are equal. And what are the powers here? X is equal to 9x minus 4. Now I have to simplify this by taking all x terms to one side and all constants to the other side. So I take this equation here, I take this equation here. So I get this as 9x minus 4 is equal to this, interchanging the left hand side and the right hand side. Then I take all x terms to one side, where x comes here as negative x and negative 4 goes to the right as positive 4. And this is how the equation can be rearranged. Next, in this case 9x minus x is 8x is equal to 4. Then in this case x would be 4 over 8. When cancel gives me 1 times and 2 times. Therefore my final further simplified value of x would be half, or 0.5. So this is the value of x which satisfies the given equation. And this is how I understand the basis and exponents and solving of the exponential equations using the laws of indices and the very special property which says that a power m equal to a power n implies m equal to n. This is a very important and special property, and the significant part of this formula is that it is used in solving the exponential equations. Now let's take a problem where the power is included for a negative base, and using this formula, because negative bases are also equally important in understanding the topic more better. So let's take a problem of a negative base. Say for example I have minus 2 whole power minus x minus 7 times minus 8 is equal to 1. Now I want to solve this equation. Indirectly I want to find the value of x using the laws of indices and the most important property which I discussed here on the top. So for that, what I'm going to do is, I don't disturb this first term. I write it as it is, as negative 2 raised to negative x negative 7 times. Now because this is negative 2, I try to make all of its bases to be negative 2 so that I can make the bases equal and then use laws of indices or use this property. So here minus 8 can be written as minus 2 times minus 2 times minus 2, because when 3 times of 2 multiplied 3 times gives me 8, and minus would be retaining back when I multiply minus 3 times, because minus into minus is plus, plus into minus is minus. So it retains back minus, so therefore this equation can be written as minus 2 times minus 2 times minus 2, and that 1 on the right hand side is undisturbed. The reason why I have written this minus 8 to be in this form is I can express this in the power form in the next step as follows. In this form. And the reason being that I want to make the bases equal as minus 2. Now after this, I identify this to be in the form of first law of index, which says that a power m into a power n is a power m plus n. Therefore this can be written as minus 2 times negative x negative 7 plus 3 is equal to 1. Now in this case I have negative 2 raised to minus x minus 7 plus 3 equal to 1. When the bases are equal, the powers are added. I have used the first law of index here. Now thus this, when further simplified, in the next step gives me minus x minus 7 plus 3, which is minus 4, equal to 1. Now I have simplified this to this extent, but which law of index am I going to identify in this case is very important, because the practice of a problem needs to be through identification of the formulae or the process in every step. Now in this step, what do I understand? Which law of index am I going to use? I have a law of index which states that a power 0 is 1. Therefore, I have to raise this to something to get 1. And what should be that something? It should be 0. So when I compare this with a power 0 equal to 1, now because I have 1 on the right hand side, this is assumed to be, I can write this as minus 2 whole power 0, because anything raised to 0 is 1 if that is a non-zero value or a number. So I write 1 as negative 2 raised to 0, because a power 0 is 1. Now when the bases are equal, the powers must be equal using the most important property. Therefore, when a power m is equal to a power n, so immediately I get m equal to n. And this equation gives me the value of x, where I have negative x on the left and minus 4 when it comes to the right is taken as 4. When negative x is equal to 4, then immediately I get x to be minus 4. So this is the value of x which satisfies the given exponential equation. Therefore, the value of x equal to minus 4 when substituted in this equation and simplified wholly on the left hand side would give me ultimately 1 on the right hand side. So the value of x, or the solution of the exponential equation, is negative 4. So this way there are many problems which can be approached in many different ways, but ultimately we need to identify through a lot of practice of problems. This being one of the case where negative bases are included.